We were taking stuff out of the rivers, trees and logs and everything, and getting all the watershed back to where it was prior to the flood. And then now we are in the business of wildfire mitigation. So you all know about that. We're working with people, with fire districts, all kinds of fire shed. What else, Will?
This program.
Yeah, we've got, this is the waste management program that we do. So you can get a dumpster for your HOA or neighborhood and collect all kinds of needles and
Pine cones.
pine cones, yeah, all that. Karen's on that.
Yeah.
And it's free to us, right?
We get funding for it from our
We get
partners
funding,
at the fire district. Yep. And waste management gives us some in kind as well.
But it's free to you all. So do it. We're taking applications right now and in May. Two times, aren't we?
Right now and then again in June.
Yeah. Okay, and the other thing we're doing is May 10th. From Myth to Reality, Wolves in the Modern Ecosystems. This is our annual symposium, May 10th, Saturday. So please come. We're still taking reservations, and it's going to be a fantastic afternoon. We've got the keynote from Doug Smith, who is from Yellowstone Park. That should be great. It will not be snowed out this year, I promise. And what else? This is our anniversary year. So we are going to have an anniversary party, commemoration sometime this year. We will let you all know. It'll be soon. Hello. Thanks for coming. Now, our speaker is Courtney Peterson. She is with Adaptive, oh, there she is. Adaptive Silviculture for Climate Change. She's with CSU and is the Forest and Rangeland Stewardship Department at CSU. Thanks for coming, Courtney. We appreciate that. Sorry you didn't drive up, but you're not missing anything. And thanks for your talk tonight.
Awesome. Well, thank you for that introduction. Any other announcements? Are you all good?
Thank you.
We're good.
Excellent. That sounds great. Well, I appreciate you letting me join you all on Zoom tonight. I'm sorry I couldn't be there with you in person. I already drove through one snowstorm this week between Iowa and Minnesota and didn't feel like pushing my luck for a second time. So even though it might have ended up being okay in the end, but gave me some extra time to cuddle my baby boy after being gone all week. So thank you. Awesome. So yes, I am the program manager for our Adaptive Silviculture for Climate Change Network. I also call it the ASC Network. And so I'm going to talk to you a little bit about the efforts that we're doing to really think about how we can be implementing climate adaptive management strategies in our forests for uncertain future conditions. And so I also work with the USDA Climate Hubs. And so we develop and deliver science-based, regional-specific information and technology about climate change to ag and natural resource managers to really help incorporate and enable those climate-informed decisions on the ground. And so Colorado is in the Northern Plains Climate Hub footprint, but we do a lot of work as well with the Southwest Climate Hub. And then I also cover the Northern Forest Climate Hub with a lot of the work that I do with our Adaptive Silviculture for Climate Change Network. So I get to do a ton of work across the country and some in Canada, which is really fun. and learn about forest ecosystems all over the US. And so the climate hubs are a great resource to keep in your back pocket if you need information about climate adaptation or climate science. And then I also work for the Northern Institute of Applied Climate Science, all these different hats that I get to wear. So I'm a climate adaptation specialist with NIACS. And we also provide that synthesis products, communication, and technical assistance in climate change adaptation and forest carbon management. And so we are, just like you, a collaborative multi-institutional partnership. We're primarily led and funded by the Forest Service, but we also have forest sector, conservation, higher education, and tribal conservation organizations as a part of our collaborative group and on our board. And so the projects and products that I'm going to talk with you about today are coming from the Northern Institute of Applied Climate Science and ASCC. And so just a quick map of what I plan on covering throughout my presentation. I'm going to talk a little bit about climate change projections and uncertainty. We're going to talk about a spectrum of climate change adaptation options and the different ways that we can respond, and then really focus on how the Adaptive Silviculture for Climate Change Network provides this great demonstration of how we are adapting our forests to climate change into the future. And so we know that our forests are in a time of rapid change. They provide essential ecosystem services, including all of the wildlife and water values that you're thinking about with the Estes Valley Watershed Coalition, as well as spiritual and material benefits. However, all of those ecosystem services that our forests provide are being put under additional pressure and dealing with shifting disturbance regimes because of changing climate conditions. And so things like the altered climate, extreme weather events, chronic stresses, different disturbances, including wildfire and insect pests like mountain pine beetle, forest diseases, invasive species, and altered habitat suitability are all posing risks to those forest ecosystem services and the carbon that they sequester. And so when it comes to thinking about climate change and uncertainty, especially for managers, it's really important that when there's no crystal ball of what the future is going to look like, uncertainty really is a myth. And so it's really up to us to embrace that uncertainty when it comes to thinking about climate change and manage for a range of potential future conditions. And it really comes down to what is our risk tolerance. And so we have fantastic climate models these days. All of the global circulation models, we're getting really great at downscaling them to local conditions and projecting out what those future considerations are going to be for local places. But where that uncertainty comes in is really in human behavior. And so we don't know which pathway we're going to take based on what those social situations and economic situations are going to be moving forward. And so this graph on the right is showing future emission scenarios represented by these shared socioeconomic pathways, or SSPs. It used to be representative concentration pathways. They updated it in the last Intergovernmental Panel for Climate Change report. So now there's shared socioeconomic pathways, and they're basically looking at how much radiative forcing are we putting into the atmosphere through greenhouse gas emissions, combined with what are those different socioeconomic scenarios going to be for future conditions? What new innovations and technologies are we going to come up with? What are the political atmospheres going to be like? And what is that going to do for how we are mitigating and adapting to future climate conditions? And so you can see there's this whole spectrum of what those potential future conditions could be under those shared socioeconomic pathways, especially thinking about the end of the century. And so as managers, it's really important, again, that we embrace that uncertainty and we manage for a range of plausible future conditions. So we can think about doing this for both the least projected amount of change to the most projected amount of change, and try to implement what we're doing on the ground to fall somewhere within that range of potential future conditions. And so I just wanted to quickly share some of the projections that we have to work with. So we know that changes in annual winter and summer temperatures are increasing, These are showing annual temperatures on the left. So the redder, the darker red, the more the temperatures are increasing by, and these are in degrees Fahrenheit. You can see there's a stark difference though seasonally. So winter temperatures in particular are significantly increasing. And then in the West, those summer temperatures are also significantly increasing. And so this is something that we have to cope with, or both what those changing temperatures are going to be, but also the seasonality of what that's going to look like. Our precipitation patterns are also changing. There's a lot more uncertainty when it comes to precipitation modeling, but we know, particularly for the Midwest and the Northeast, that precipitation is going to really increase. In the West, it's very likely to decrease, particularly in the summer. And then when it comes to some of those winter seasonality changes, we're seeing less snow, earlier snow water equivalents, where we're getting that snow melt on April 1st. So that's happening sooner and sooner. And we're having rain on snow events. So we're seeing a lot more of that earlier snow melt and flooding and erosion. We're also experiencing really hot and cold extremes. And so it's much more likely that we're going to experience those really hot days above 90 degrees. We're going to have fewer cold days, and we're going to have a lot more warmer nights. So nights that are above 70 degrees Fahrenheit. So that's something particularly for the Front Range of Colorado that we're going to be grappling with, or we're not getting those cooler nighttime temperatures. And then, as I mentioned, again, we're experiencing continued decreases in snowpack, and that is projected towards the end of the century as well. And so this is really showing, particularly for the western slope of Colorado, we're starting to see the amount of water stored for our snowpack, and those regional supplies are going to continue to decline, especially at higher elevations. And then this also leads to increased flooding risk. And so this is showing the annual average loss from all types of flooding in 2020 compared to what it is projected to be to 2060. And so this is the amount of cost of things lost due to flooding events. And as you all know, it's very likely we're going to continue to have these 100, 500-year flooding events more frequently. And so this is something that we're going to have to continue to grapple with, and the costs associated with mitigating all of the impacts from those flooding events as well. This is also showing our cold hardiness zones. So this is a great indicator of, if you like to garden, what you can plant and what is going to grow well based on frost tolerances and heat tolerances, but particularly thinking about those hardiness zones for those colder temperatures. So this is showing the historical cold hardiness zone for Estes Park, which is on average a negative 7.5 degrees Fahrenheit, or a 6A. Thinking towards the mid-century, so 2040 to 2069 average, so thinking around 2050, it's very likely that the cold hardiness zone for Estes Park is going to be a 7A, so only getting down to about 0 degrees Fahrenheit as those cold temperatures that our plants have to be adapted to in the future. See if I can, there we go. We're also dealing with more non-native invasive insects and diseases. And so this is, as we get those changing precipitation patterns, more drought, warmer temperatures, non-native invasive species really thrive in those conditions. And so it is very likely that we're going to continue to have increasing presence of non-native invasive insects and diseases in our forest ecosystems. And then this is also showing some of those seasonalities associated with infectious diseases. And so particularly things like Lyme disease in the Midwest, there's a huge increase. It's very likely we're going to be seeing more ticks, even in places like Estes Park. So thinking about how can we mitigate some of those health impacts is going to be something that we have to consider, especially as we're recreating in our forest ecosystems moving forward under a changing climate. And then we're seeing those phenological mismatches. And so we're seeing shifts in the phenology and range of different species. So when things are budding out versus when pollinators are there and available to pollinate them, when our migratory birds are flying. We're seeing changes in Colorado and when bears are coming out of hibernation, and what that means for what food is available in the spring and what's still available with shorter frost-free seasons in the fall. And so these are all things we're going to have to grapple with, especially when it comes to human and wildlife interactions with those bears, as well as, again, those phenological mismatches of plants that need to be pollinated and seed dispersals. And then we're also experiencing longer and more severe wildfire seasons. So we don't really have a fire season anymore. We are seeing fires throughout the entire year. And our fire seasons are getting longer. The conditions, we're seeing a lot more of those red flag days. So the potential for fires to be started is increasing, and it's very strongly correlated with our drought conditions. And so you can really see with that changing graph on the right, the darker red is when we have those extreme drought conditions, and it's very strongly correlated with when we've had some really large fire events, especially in our 2020 fire season. And so that's something we're just going to have to continue to grapple with, is our firefighting capacity. We're used to sending our firefighters across the country for different seasons because of when those fire seasons occur in different forest ecosystems. But we can't really do that and plan on that anymore. And so we're really going to have to be grappling with limited capacity for both firefighting and implementing prescribed fire on the ground. And then we're also seeing a lack of regeneration of our forest ecosystems post-fire. So this is an example from the Hayman fire in Colorado Springs. And so we're really starting to experience 20 years post-fire, there's still no seedling regeneration in this forest. And one, it's because that seed source is too far away. The fires are burning so hot and intense and severely that the soils are not taking seeds so that those next cohorts and generations of trees can regenerate and grow. And we're also just not seeing conditions that are suitable for those new species, for those new trees to really take root and take off. So there's that lack of seed source nearby, and those soil conditions are not appropriate after those really hot, intense fires occur because those soils become hydrophobic and unable to take in that seed source. So there's also, we're dealing with climate disasters that are causing more and more billion-dollar disasters. And so on average, the US is experiencing a billion-dollar weather or climate disaster every 3 weeks. And so those are things like severe droughts, extreme floods, severe storms, tropical cyclones, and wildfires, as well as winter storm events. And the ones we typically have in Colorado are those hail events that cause those billion-dollar disasters. And then this is just a graph showing what does that 3.6 degrees Fahrenheit or 2 degrees Celsius of global warming actually feel like in the US. And so we're particularly seeing, again, those increasing temperatures, lack of cool nights. And so there's heat stress and concerns for some of our vulnerable populations around what those extreme heat days are going to be like, particularly in the summer. And so all of that is creating just one more additional challenge that we as foresters have to think about. And so we already have to think about what are those natural forest dynamics? What are our management goals and objectives? Are we trying to make revenue off of a timber sale? What are some of our forest health considerations? What are past and future disturbances going to be? What wildlife habitat are we trying to maintain? What are our management plan requirements? What invasive species already exist within our forest stands? And on top of all of this, we also have to be thinking about climate change. And climate change basically exacerbates all of these challenges and gives us numerous stressors that make it more challenging to meet those goals and objectives. So how can we respond? We can think about this in both terms of mitigation, so those actions that help reduce greenhouse gas emissions and enhance carbon sinks, and adaptation, which is what we really focus on with ASCC. And those are those actions to reduce the vulnerability of systems to climate change effects. And a lot of the actions that we implement can be both mitigation and adaptation actions. So planting new trees is a great example of something that sequesters greenhouse gas emissions and can help our forests adapt to future conditions. And so again, with mitigation, we're doing a lot of what are some of those new technologies? How can we have renewable energy? How are we changing consumer behaviors? And what are some of our changing management practices that really help reduce emissions and sequester greenhouse gases? And there's a ton of states and cities that have already taken action to do this. Colorado has a lot of plans, and especially some of our cities along the Front Range have their own greenhouse gas mitigation plans and targets that we are trying to achieve. And so I'm pretty sure we were trying to reduce our greenhouse gas emissions across the whole state by 25% by this year. I don't know if we're on target for that or not, but we at least have those targets that we are working toward. However, and then the other thing I wanted to point out, there are these natural climate solutions that have been identified that create this climate mitigation potential. And I'm sure you can't read this list in the room, it's way too small, but the one across the top that sequesters the most greenhouse gases and is one of our best natural climate solutions is reforestation efforts. And so the more we can do to benefit reforestation, particularly in Colorado after we experience these large insect and disease outbreaks and wildfire events, are reforestation efforts. However, we know, again, that a changing climate puts the forests and that carbon that they sequester at risk through things like those insects and diseases and fire, extreme cold, and some of those different climate stressors and disturbances. And that's where adaptation really comes in and becomes even more important. So again, this is the adjustment of systems in response to climate change. And the things we're already doing that are sustainable management and conservation and restoration practices are really effective, fantastic adaptation actions, and just more important because of climate change. And ultimately, what it comes down to with adaptation is, what do you value? What are your goals and objectives? What are those ecosystem services within our forests that we are trying to provide? And how much risk are we willing to tolerate under a changing climate? So thinking back to that spectrum of shared socioeconomic pathways, we could end up at a low scenario, we could end up at a high emissions scenario. And so it's really up to us of what is our risk, where are we going to fall within that spectrum, and how are we going to implement adaptation actions on the ground that help make sure we can continue to achieve the things we value out of our forest ecosystems. And so as a silviculturist and a forester, I always like to think of what this could mean in terms of desired future conditions. And so we know what our current condition is. We know what the stand structure and composition and function of that forest is. And we have a picture in our head of 5, 10, 50, or 100 years of what we want that forest ecosystem to look like in terms of structure and composition and function. And that's our desired future condition. However, climate change pulls that desired future condition in that uncertain trajectory. And so it's really up to us to figure out what actions are we going to implement through our management on the ground to still achieve that desired future condition under a changing climate. And so the big question that we are really trying to answer through the Adaptive Silviculture for Climate Change Network and the work we do at NIACS and the Climate Hubs are, what actions can be taken to enhance the ability of a system to cope with change and still meet our management goals and objectives? And how can we create robust, clear plans that are documenting our thought processes so that future managers know what we're trying to do and why as well? And so with the Adaptive Silviculture for Climate Change Network, or ASC, it really provides this venue to explore those silvicultural or forest management options for climate adaptation. And we've been doing this by developing and implementing this experimental framework that's testing a suite of climate adaptive management actions. And so we're really trying to provide this experimental context that's testing this range of responses, because we know we are going to have a range of potential future conditions under a climate change. We're also evaluating and comparing those intentionally designed treatments for resistance, resilience, and transition. And so I'll go into each of those in a little bit more detail here to tell you what I mean by those 3 adaptation options. We're really doing this by fostering collaborative science management partnerships. So each site is really co-developed by both managers and scientists coming together with community partners to figure out what should these actions look like for resistance, resilience, and transition in these forest ecosystems. And then they give us information and insight that we can share with the broader community so that we can figure out how should we actively be responding to climate change in our forest ecosystems. And so I keep saying silviculture. Some of you might be wondering what I mean. And so just quickly, silviculture is defined as the art and science of controlling the establishment, growth, and composition, health, and quality of forests and woodlands. And so that art and science piece is something that's really important when we're thinking about silviculture, because it really depends on what are those current conditions on the ground and how are we going to get there based on our toolbox that we have in our pockets of managers to really create those desired future conditions. And the other key part about this definition is that we're doing this to meet the diverse needs and values of landowners and society. So how are we continuing to provide those key forest ecosystem services such as wildlife habitat, timber, water resources, restoration, and recreation on a sustainable basis into the future? And so the role of silviculture is really important when we're thinking about climate adaptation. It basically is this whole suite of toolboxes that we can use as managers to carry out management on the ground. And so one of the things that's inherent to the silvicultural process is, again, clearly defining what those desired future conditions or outcomes are that we really want to achieve by shaping what is the future composition, age and structure, tree size distributions, habitat qualities on the ground through what we're doing with our management, and then planning and implementing those actions to really achieve those desired future conditions. And so it's really this iterative process where we're constantly evaluating and reevaluating how our forests are responding to the management that we're implementing on the ground. And the lessons of the past are really important for informing our decisions of how we do this for the future. And so the challenges and urgency of climate change have generated a need for this modified adaptive silvicultural response. And so we're really trying to constantly be using this iterative process, using that art and science of our forest management that we're implementing to figure out how can we adapt to these changing climate conditions. And so the Adaptive Silviculture for Climate Change Network, we have 14 sites across the US and Canada. So there's 2 in Canada, the rest are in the US. And all of them have these key partnerships between scientists and managers who have come together. They're really championing these sites and thinking about how can we really implement these treatments for climate adaptation into the future across these diverse forest ecosystems. And so you'll see we have 3 sites in Colorado, and they really span this forest type gradient from lower elevations to higher elevations at the Colorado State Forest. And so I'll provide some examples of what we're doing with our treatments there. We also have a leadership team. So Linda Nagel is the thought leader and really the principal investigator of this whole network. Maria Genoviak is our US Forest Service lead and helps make sure we have a lot of funding so that we can do this work. I manage the whole network as the program manager, and then Maria Vicini is our program coordinator and helps a lot with science delivery and outreach and communication of the work that we're doing. And then we also have Chris Swanson, who is one of the original thought leaders of this project as well. And he is currently the head of research and development with the US Forest Service. And so we use this process called the adaptation workbook and how we come up with our ASC treatments. And so it really is this 5-step adaptive management framework that provides a climate filter to each step and is really centered around what do managers and our community members value about the forests that we're managing and living and recreating within. And so it's really centered in how are we going to continue to achieve those values with our management on the ground under a changing climate. So we start with where are we working, what are those goals and objectives, and what are our management timeframes? And then we bring in vulnerability assessments and scientific literature and traditional knowledge to really assess those climate impacts and vulnerabilities and really figure out what are they for each local forest ecosystem where we're creating one of our ASC sites. Then we evaluate our management goals and objectives given those climate impacts. So what are those climate challenges? What are those climate opportunities? And how are they really going to influence the feasibility of achieving those goals and objectives? Or do they need to change given climate projections? And then we take all that information and use it to really come up with these ideas for adaptation actions and really identifying and implementing what those adaptation tactics or actions are going to be. And then making sure, especially since this is an experiment, we are monitoring and evaluating the effectiveness of our actions into the future to make sure we're still achieving our goals and objectives under those climate projections with our adaptation actions that we've chosen to implement. And so I keep saying we're testing this spectrum of adaptation options. So we're really trying to think about how can our forests respond across this robust range of potential future conditions by really thinking about resistance, resilience, and transition. And so with resistance, to dive into this into more detail, this first adaptation option we define as improving the defenses of our forest ecosystems against anticipated change or directly defending against disturbance in order to maintain relatively unchanged conditions. So this is really our homeland security adaptation option. We're really trying to protect those things of high value over the short term. And so actions such as knowing where we have really key road crossings or we have really key transportation infrastructure, but it's going to continue to experience these flooding events and continue to be washed out. How do we improve that infrastructure so that it can continue to withstand these flooding events is a great example of a resistance adaptation action. Maybe we have a threatened or endangered species in our forest, and so we're trying to do everything we can to maintain that structure and composition and function of that forest because that's where that threatened and endangered species thrives. And so that's another example of a resistance adaptation action. And then we might also be trying to prevent the establishment of invasive species in our stand. And so the actions we take to try to prevent those encroaching invasive species are examples of resistance actions as well. And so this is really thinking about, again, we have that current condition. We know what that structure and composition and function of our current stand or our forest is. And we have that desired future condition in our minds where we really want to maintain that similar structure and composition and function of that forest into the future. And so we know that there's a potential future range of variability. And with resistance, we kind of have this limited range of acceptable outcomes because we really are trying to maintain what is on the ground under those climate change impacts into the future. However, we know that to maintain those current conditions is really going to require increasing resources and capacity and investments and funding to maintain that desired future condition, especially the farther out into the future we go with those more extreme climate projections. And so we are accepting more risk to maintain what's currently on the ground under a resistance adaptation strategy. With resilience, we're really trying to accommodate some degree of change or disruption to the system, but encourage a return to a similar condition after those disturbances occur. So this is our rubber band adaptation option. We want those forests to experience those disturbance events, but be able to really quickly bounce back after they occur. So things that improve overall forest health and vigor, or going in and managing vegetation following those disturbances are examples of resilience adaptation actions. So for example, we know that our ponderosa pine forests are extremely adapted to frequent fire events and those low severity frequent fire return intervals. And so going in and implementing some prescribed fire in our ponderosa pine forest ecosystem would be a great example of a resilience adaptation strategy. We also could go in and we know with our lodgepole pine forests, those really thick overstocked stands are really prone to mountain pine beetle infestations. And so going in and reducing those stocking levels, taking out a few of those trees so that there's a little bit less competition could be another example of a resilience adaptation action. And then maybe we have a seasonal wetland and we know it's going to experience both drought and extreme precipitation events. And so whatever we can do to really allow those seasonal wetlands to fluctuate with those water levels during those drought and extreme precipitation events is another example of a resilience adaptation action. And so again, with resilience, we know what's on the ground with the current condition, And we want that desired future condition to be something that's similar in composition and structure and function, with maybe a couple of small changes or tweaks. And so that range of acceptable outcomes you'll see is a little bit wider. We're okay with a few changes to that current condition with that desired future condition. And that squiggly line is representing those disturbances occurring to that forest and really quickly being able to bounce back to that similar condition. But again, with resilience, to maintain that similar condition into the future under a changing climate is going to again require increasing resources and capacity and accepting more risk to maintain those similar conditions. And then our third adaptation action is transition. And so this is where we are intentionally accommodating change and enabling our ecosystems to adaptively respond to those changing and new conditions. And so the key thing with transition is that we are still creating a forest ecosystem that provides those values and achieves our management goals and objectives. And so doing things that might foster well-adapted native species, maybe we're thinking about assisted forest species migration, because we know that there's going to be some southern species that are going to do well under a changing climate. We could be planting some of those new species as well. Those visitor infrastructures or those road crossings that continue to experience those extreme flooding events, instead of maintaining them where they are, maybe we decide to relocate them. That would be another example of a transition adaptation option. And then with our rivers and riparian areas where we've really changed the sinuosity, we could go back and we can restore some of that original sinuosity to our river and riparian areas following some of those ag events. And that could be another example of a transition adaptation action. And so with transition, you'll see that that desired future condition looks pretty different from what that current condition on the ground is. And so again, we're really being intentional about what we're trying to create with that desired future condition to still achieve our forest values. But we're hoping there might be a lot of experimentation and a little bit more risk up front, but over time, hopefully that risk and investment and capacity to transition to something that's tracking with those climate projections will decrease over time. And so again, the key thing is that we're really explicitly considering how we're addressing climate change through our actions. We're not just throwing spaghetti at the wall and seeing what sticks and hoping to be lucky, but we are intentionally assessing our climate risks and making our plans more robust by thinking across this spectrum of resistance, resilience, and transition, and the suite of climate adaptive silvicultural practices that we can use to get there. And so again, for ASC, all of our sites are created through this co-produced collaborative workshop. We come together, we've done this both in person and virtually during the pandemic, and we really think about what are those desired future conditions for resistance versus resilience versus transition for all of the forests that are a part of the network. We really start with what are those current conditions and how are we going to get there through the different silvicultural treatments that we're going to implement on the ground to achieve those desired future conditions for each adaptation option. We have some pretty common experimental design criteria for all of the sites. So we're testing resistance, resilience, and transition at all of those forests that are a part of the network. We also have a no action control. So we can't have a true control because we're dealing with forests, and we know that climate is naturally going to influence some of our forest ecosystems, but we at least have the control where we are not implementing any management intervention to see how our forests are responding. We also, all of the sites are replicated a minimum of 4 times so that if a hurricane comes through, which has happened to one of our sites in Georgia, and wipes out one of the treatments, then we still have others that might be unaffected that we can continue to compare to those disturbance impacted stands. Also, we're thinking we want all of the blocks. So we have all of our treatments and blocks of resistance, resilience, transition, and no action. And that's replicated 4 times. And each little unit is 20 acres in size. And so that's a pretty stereotypical management operational unit. So we can do some cool silviculture within that size, but it's also feasible to implement and replicate 4 times. We have some monitoring guidelines. So we're going in and we're looking at overstory, midstory, and understory after all of our treatments. every year, 1 to 5 years, and then 10 years, 15, and 20 years into the future. And so since this is a climate study, all of the site leads really are championing these sites 20 years into the future. But then each of the forests also have unique characteristics that are specific to their sites. So the forest type is going to vary depending on where you're located. The layout is going to vary depending on slope and aspect and soil conditions. Management goals are going to differ from forest to forest. And so the treatments that we're implementing to achieve those desired future conditions is also going to vary from forest to forest for each site that is a part of the ASC network. And then it is one of these, when you build it, they will come. And so as we have implemented these on the ground, we have more researchers coming to us who are like, oh, I want to see how pollinators respond to these treatments, or I want to see how migratory birds are responding to these treatments. I want to see how we're sequestering carbon through our soils after we implement some of these actions on the ground. And so we can really start to ask some really cool questions across all of our treatments as well. These are just some quick examples of what this can look like on the ground from 3 of our different sites. So you can see, again, we have these blocks of resistance, resilience, transition, and no action control. And then within each, there's plots that we're using to monitor how are our forests and those mid-story, overstory, and understory responding to what we're implementing on the ground. And so we use a standard forest inventory and analysis plot. So it's a 5th acre plot, and then we're again looking at all of these different variables for species composition, density, diversity, forest health indicators, and productivity, and really seeing how are all of these different measures responding to what we're implementing on the ground. So now what I want to do is provide some quick examples of what we're doing in Colorado. So I'm going to dive into our 3 Colorado sites just to give you an example of what we're actually implementing for resistance, resilience, and transition. And so the forest ecosystems that we're dealing with across the Southern Rockies, they really are fire-driven ecosystems. And so we have a lower elevation ponderosa pine and mixed conifer forest. And so it's composed of ponderosa, Doug fir, aspen, juniper, white fir, and Gamble oak. And it's really used to having fire every 7 to 50 years at low severity that stays on the ground in these small patches. Sometimes it can be stand replacing in those small patches, but mostly it's these surface level fires that occur frequently in those ponderosa pine forests. We also have a site in a lodgepole pine ecosystem on Taylor Park on the Gunnison National Forest. And so this is where we're used to more of those lodgepole pine with occasional mixed conifer within it. And we experience these stand replacing fire events that then cause the forest to regenerate. So lodgepole pine is really great at regenerating after fire occurs. And we start this whole next generation of a forest stand after that lodgepole pine forest experiences fire. And then we have one of our Colorado sites in the subalpine fir and Engelmann spruce forest ecosystem. And so it's really co-dominated. We have subalpine fir, Engelmann spruce, and lodgepole pine as the main tree species within this forest ecosystem. And it is really used to having these really infrequent, every 100 to 600 year stand replacing fires. And then eventually a new forest will regrow. And it's not quite like lodgepole where it immediately resprouts and starts to regrow because of those fire adapted cones that lodgepole pine has. It takes a little bit more time for the forest to regenerate following those fire disturbance events. And so again, what we're dealing with these forest ecosystems that also have some extreme insect and disease challenges. So we know mountain pine beetle, especially in Estes, is one that we've been struggling with. There's spruce beetle across these forest ecosystems. We're dealing with extreme wildfire. So what our site at the Colorado State Forest is directly to the west of where the Cameron Peak fire burned. And so all of these are things we're dealing with and that are exacerbated because of climate change, with those increasing temperatures, earlier snow melt, shortening frost-free seasons. So those beetles are able to maybe have more than one life cycle throughout a season. And so these are all challenges that we're dealing with when we're thinking about our forests, where our sites are in Colorado as well. And then finally, we're also thinking about moisture gradients and where are our forests occurring. And so we have that dry mixed conifer forest on our San Juan National Forest. And so it again has that low to moderate fire severity. We have our high elevations, subalpine fir, spruce fir forest at the Colorado State Forest with that mixed to high fire severity. And then our lodgepole pine forest is actually our highest elevation one on the Gunnison National Forest, but it is that mixed to high fire severity because of those moisture gradients and a slope and aspect that we're dealing with these stands as well. So thinking about resistance, resilience, and transition across these three forest types. With resistance, again, we're really trying to maintain those structures, compositions, and functions of this dry mixed conifer forest on the San Juan, this spruce fir forest at the Colorado State Forest, and the lodgepole pine forest at Taylor Park. So for resistance with the San Juan National Forest, we're reducing density, trying to maintain composition, and going in and doing an even spaced thinning. So we really are trying to just reduce competition. So we're preventing some of those insect and disease outbreaks in this mixed conifer forest type. With the state forest, same thing. We're going in and we're reducing density and maintaining that spruce, fir, and lodgepole pine composition. And then with Taylor Park, that lodgepole pine forest, we're going in and we're thinning the lodgepole pine stands, but we're trying to retain some of those spruce and fir where they are. So again, you'll see that theme, reducing density to reduce competition, but maintaining that structure and composition. With resilience, this is where we want our forests to be able to bounce back from disturbances. And so the theme you'll see here is we're really trying to enable some change. And there's a lot of how are we thinking about increasing diversity and encouraging heterogeneity within these stands. So we're doing a variable density thinning within the San Juan National Forest. So we're really going in and we're messing with the structure and the composition and the age cohorts so that there's a little bit more heterogeneity. It's a little bit harder for fire to travel and have those ladder fuels by changing that heterogeneity. At the state forest, we're doing a group selection. So that means we're creating these gaps so that we're allowing more sunlight to access the forest floor. And then we're going in and planting some local stocks of native plants that are spruce, Engelmann spruce, subalpine fir, lodgepole pine, and a little bit of blue spruce. And then at Taylor Park, we're doing what we call a group shelter wood. So this is where we're, again, creating these gaps. We have some feathered edges, but we're basically trying to encourage more sunlight to reach the forest floor. And we're doing this and so that we can plant some local stock of lodgepole pine in the Taylor Park site as well. And so you'll, again, with resilience, we're increasing diversity and we're increasing heterogeneity. And then with transition, this is where we're intentionally facilitating change to something that's future adapted. And so we're really going in and we're mixing things up. So we're doing some variable spacing with larger openings and that mixed conifer forest on the San Juan National Forest. So we're really trying to think about, we're going to have more fire. We want to get rid of those ladder fuels. We want to have these gaps in the canopy so that fire can't necessarily carry into the canopy. And we're opening up spaces so that there's the potential for that natural regeneration of some of those mixed conifer species, including ponderosa pine and Douglas fir. At the state forest, we're creating even bigger gaps. And we're actually going to plant some of those mixed conifer elevation species, including ponderosa pine and Doug fir, in our spruce fir forest elevation. So we're really thinking about how fire return intervals at that high elevation are going to become more frequent under a changing climate. And so having things like ponderosa pine and Doug fir that are used to those more frequent fire events at that higher elevation might ensure that we still have forest ecosystems there in the future. And then with Taylor Park, we are going in and we're doing a clear cut with reserves. So it basically removing a lot of the trees, but maintaining some of those really key legacy trees that have that local seed source and stock that provide that future generation of lodgepole pine, but then also implementing some prescribed burning and then planting a ton of different future adapted species within those larger gaps and clear cuts. So we'll have both that lodgepole pine native stock, but also some of those future adapted species that we can think about in terms of ponderosa pine and Douglas fir and sourcing them from some of those southern seed sources, maybe even from New Mexico. And so what we're really seeing again is with resistance, we're maintaining what's currently on the ground. We're doing a lot more density management and really focusing on reducing impacts from disturbance. With resilience, we're increasing that ecosystem complexity and then increasing diversity with what we're planting with some of those native species. And then transition, we're intentionally facilitating change and increasing the focus on regeneration of future adapted species in larger canopy gaps. So those are some of the themes of what we're doing, particularly in our Colorado sites. The other thing that I wanted to talk about really briefly, and then I'll open it up for questions, is we are doing forest-assisted migration at our ASC sites. And so there's a whole spectrum of forest-assisted migration, just like there is with resistance, resilience, transition. And so the 3 types of forest-assisted migration, one is assisted population expansion. So it's the movement of species or genotypes relatively short distances, with the expansion occurring contiguously within that species' current distribution. There's also assisted range expansion, which is the movement of species to suitable locations adjacent to, but slightly outside of their current range, but it's able to get there through natural dispersal. And then there's assisted species migration, which is the assisted human movement of long distance migration of species across areas where there might not be able to get there by natural dispersal because there might be a natural migration barrier. And so we're thinking about all 3 of these different types of forest assisted migration with what we're planting with our ASC sites. We're also taking into consideration what are the silvics of the species? So what is their shade tolerance? What is their fire tolerance? What is their drought tolerance? What is their dispersal capability? Is it via pollinator? Do they spread their seeds? Does wind disperse them? All of those things are things we have to consider when we're thinking about what species we want to plant and where. And so across the 3 Colorado sites, you'll notice with resistance, we want to maintain that current composition, so we're not doing any planting of assisted migration and resistance. With resilience, we are doing a little bit of planting. So we're thinking about how can we have that population migration and some range expansion. So planting things like Douglas fir, limber pine, Engelmann spruce in that high elevation forest, as well as in Taylor Park in that lodgepole pine forest. And so we're really thinking about expanding the ranges of some of those native species. And then with transition, that's where we're really starting to think about some of that species migration, especially at the state forest. So we're planting some future adapted shrubs. We want to have bristlecone pine. We're moving in ponderosa pine and limber pine as well. And so we're thinking about that switch from a spruce fir forest to that mixed conifer forest type and composition. So we're really starting to think about how can we expand what we're planting by really thinking about some of these climate adaptive characteristics of these different species. And the one thing that is a challenge with all of these sites is our reforestation pipeline. And so getting the right seed from the right place based on climate models is one thing, but then the nurseries also have to have that available. It's been a challenge trying to make sure we have the correct genetic stock. We can do a lot of sourcing locally, but when we want to do some of those genetic diversity and southern genotypes, then sometimes we're running into challenges where nurseries don't have the seed sources that we're hoping to plant at some of these higher elevations where we need to source them from these southern locations. So these are all things we're trying to overcome with the work that we're doing. And then I just want to end with, again, we are really thinking about, we're going to have this range of potential future conditions in the context of a changing climate. And so it's really important for us to respond through this robust range of adaptation options from resistance to resilience to transition. And so doing things like increasing diversity, increasing structural complexity, focusing on regeneration, and really thinking about both future and novel species are tools that we can use to really help our forests be more adapted to these climate impacts in the future. So just a few concluding thoughts. With climate change, we know that certainty is a myth. It's really important that we plan for this range of potential future conditions. Tools are helpful, but ultimately the managers working on the ground know these areas best. You as residents in Estes, you know what your forests are, you recreate there, you see what's growing on the ground. And so judgment of what's going on the ground is really critical. Climate-informed choices are not always going to be ideal. So we know resistance requires more risk and investment and capacity, but if we have that threatened and endangered species in our forests, we need to make sure that it can continue to persist into the future as well. And so it's really important that we're clear about what we value and what our intent is through what we're trying to do on the ground. And especially when it comes to those long-term climate projections for the end of the century, we don't know what our forests are going to look like. And so we're doing the best we can to try to get there. And what we're doing with transition is a lot of experimentation, and we have to learn by what we're trying to implement and do on the ground so that we can continue to have these forest ecosystems that provide value to us in the future. And so I talked a lot. I'm sorry about that. Thank you all so much for your time. And hopefully we have a couple of minutes for some questions.
Thank you. Yeah, that was a really good class, so she had to get out there. The packed house here. I had two questions. One was the invasive species in the Northeast. That was huge. And the other is how far along you are on the projects on these plots.
Awesome. Yeah, those are great questions. So invasive species in the Northeast, there's the Northeast Invasive Species and Climate Change Council or something. It's the risk. They have a ton of models, and it's really showing, especially because they're going to experience more precipitation, just the potential for those invasive species that are already there. It's just going to continue to balloon under those conditions. So they're really great at taking advantage of those extreme precipitation, as well as those paired with those higher temperatures. And those are great conditions for some of those invasive species to thrive, especially the ones in the understory. The plants, or where we're at with some of these treatments, we have one in Minnesota. It's our oldest site. It was implemented in 2014, so it's 11 years old now. And so we've got some great data of what's working and what's not working. So the assisted migration, for example, that we did there, we planted ponderosa pine and a red pine stand, and it was either go big or go home. It either died instantly or it's the best growing tree in that stand right now. So we have some cool lessons learned through what we've been planting there. Our sites in Colorado are all getting harvested right now. So the one at the state forest, they've gone in this winter and they're creating those gaps. And so we're hoping to plant either next year or the year after. So we'll have some information on what's working in the next couple of years at our Colorado.
I had heard on the radio that they're planting trees at a higher elevation to make them more resistant. Is that true?
Yes, so that's what we're trying to do with our forest assisted migration studies. And so we're taking species from those lower elevations and trying to plant them at higher elevations, because we think that that's what those higher elevation conditions are going to be like in the future. So those warmer temperatures, more frequent fires, more drought conditions at those higher elevations. So we're hoping by taking species from those southern locations or lower elevations that are used to those warmer temperatures and planting them at higher elevations, that they will be able to survive in those future conditions, whereas some of our higher elevation trees who are used to these historic climate conditions with longer winters, colder temperatures, might not be able to do as well in the future.
Hi, I wanted to ask you how there are 12 sites in the United States, I counted. Are you disseminating information to the rest of the states that are not involved, the rest of the forests, and how?
Great question. We are. We basically, the sites that have been established at this point, they've come to us and they're really excited to create these treatments and sustain them 20 years into the future. It's a lot of work. So not everybody wants to do it. But we're able to take what we're learning through what has been implemented in those 12 states and we do share it. I do a lot of trainings with natural resource managers, and so I travel all over the country and do workshops, talk about what we're seeing on the ground, what's working and what's not working, what they could try for their goals and objectives. And so there's a lot of doing those trainings in those states where we don't have sites, so that we're thinking about resistance, resilience, and transition, even if they're not adaptive silviculture for climate change forests.
Thanks very much for all y'all are doing. I'm wondering now, since you have climate change in your program name, is the new administration trying to shut you down?
That's such a loaded question. So we are primarily federally funded, and so that has definitely been a challenge that we've been dealing with. I am based out of Colorado State University, so there's a little bit of a buffer because our program management is housed within the university, and so we have funding that's obligated already at the university that can't be taken back. But yes, that's something we're worried about, especially for future funding over the next couple of years, is how are we going to pay to continue to monitor these treatments if we don't have that federal funding support. The nice thing is it is a network. We have partners who are federal as well as non-federal or private, nonprofit. And so we're kind of able to pool our resources and capacity with personnel to be able to still make the science happen on the ground. But it's certainly something.
My question is right on top. My question is right on top of his. I'm going to buy you a thesaurus because we got to get the word climate change out of your title. The value of this research is that it continues and that it's done in a certain way every year. And if that should get yanked, I just can't imagine the loss to your program. So put your thinking cap on and think of a new name, and we support it, whatever it is.
Thank you. I appreciate that. Yeah, a lot of what we're doing, I mean, we could just say we're doing adaptive silviculture, and I feel like that probably is going to fly just fine. If we drop then we don't have the ASC acronym. That's the only thing. But yes, I think we are continuing to emphasize that the work we're doing is to ensure we have forests that are providing products into the future, and we are addressing disturbances and risks to our forests like wildfire and insects and diseases. And so the more we can communicate that we're doing that work, the better.
My question has to do with the ability of the species to deal with this uncertainty. Are you taking measurements of, let's say, physiological characteristics, how much natural variability there is within a species to be able to tolerate these changes, or the phenotype to change as those conditions change? Classic Red Queen hypothesis, where you have to run as fast as you can just to stay in the same place under certain conditions. But now with the rapidity of the fluctuations in the environment, are there physiological measurements looking at the range of variability within species to predict their ability to adapt?
That's a great question. We are looking at that. So we can do a lot of phenological measurements with our trees. So we can see when are they budding out for our deciduous species. We can also see how are they tolerating frost conditions. We are looking at how are they doing under drought conditions. And so we can do some of those smaller tests on the seedlings that we're planting just to see how they're surviving and how much growth they have. And then with our more established trees, we're also continuing to look at how are they growing, under what conditions. We can look at the tree rings and see what their historical climates have been. And so there's a lot of really cool research that's done by a lot of my colleagues to really think about that plasticity and how current species that are well established are doing versus what we want to plant. There's a lot of great tools and models out there, but honestly, there's not as much like on the ground examples of how to do this yet. And so this project is one of these novel experiments where we're trying to provide examples and test some of these questions because we don't know how these species are going to do. We don't have a ton of common garden studies really looking at what this is going to be moving trees up and down elevational gradients. And so we're trying to provide that and don't have the answers yet. We can figure out based on models where we should be sourcing from, what are the drought and frost and adaptive capacity and dispersal characteristics of our seedlings that we want to plant, and use that to figure out what to plant where and where it should be coming from. But we don't ultimately know how it's going to do in the future, which is why this work is really important. So we're trying to answer those questions. And then going in and monitoring and measuring how are those seedlings growing, how are they responding, which ones are surviving and which ones aren't. And so hopefully we'll have more answers for you in a couple of years.
We'll have you back then.
Certainly ought to.
Thank you so much, Courtney. This was great. It didn't matter that you weren't here in person. I need to be up.
We did have one on one question on Zoom.
coming up.
How long does it take to go through a whole cycle?
That is a great question. Yeah, so to go through the whole cycle of establishing a site, there's a lot of pre-work up front. So we do a ton of how can we meet with the community? Is there interest? It is really important that it's co-developed by the managers and the scientists. We don't want this to just be scientists coming in saying this is what we think you should do for resistance resilience transition. So it's really important we have that manager who's going to ultimately be the one implementing these treatments on the ground to achieve their goals and objectives, who's interested as well. So that takes at least a year to get all of that together. Then we go through this workshop process. And then there's usually a year after that where we're planning, trying to figure out where can we get the seedlings from for resistance resilience transition, who's going to do the implementation on the ground. Are we going to do it in the winter or the spring or the summer? And then are there any policy requirements we have to go through, like NEPA or state policies, before we can actually implement? So that adds a couple of years as well. Then we can implement the treatments with the harvest and then go in and plant. So all of that's already a couple of years, like 5 have gone by. And then it is a climate study. So we do pre-treatment monitoring and take measurements. We implement the treatments, and then we're hoping to monitor all of these sites at least 20 years into the future. So really it's like a 30-year-long study.
A lot of variables. Anybody else? Yes.
I mean, there were a lot of comments about the financing and all that, and I don't want to go into that. I see the financing as a big problem looking ahead. How we're going to handle this. I think a lot of people are not aware what's coming, what's ahead of us. I think it's very important what you're doing. Just one question is more Estes. Where does the aspen tree stand in all this?
That's a great question. I think aspen is tricky because it's not great at dealing with drought, but then it also has been like really, it's a great resprouter. It does well under variable conditions. It grows on different aspects and different soil conditions. And so I think and it's great when we're thinking about fire. And so aspen, I'm not sure how aspen's going to do in the future, because if it experiences that really big drought, it could have that big die-off event again. But it also does pretty well under some of our like changing temperature and precipitation and their conditions. And so I don't have a great answer for you, and hopefully it'll be one we continue to have those beautiful fall colors of in the future.
Anything else, everybody? Thank you so much, Courtney. We really appreciate it. Keep up that fine work, and we'll have you back in a few years. And go take care of that baby.
Thank you. I really appreciate it. Thank you all for your time.
Thank you.